Never mind. I thought I was gonna request to record, but it just went and recorded. Cool. Um, cool. Yeah, this is just a quick follow-up to the last architecture meeting. Wanted to see if people have any questions on like the last stuff that we talked about. Um, or any questions related to that, or like the work that you guys are doing. So yeah. London, you have anything? Derek, Yeshua, Victoria? No questions? You can literally ask anything. It's not, there's no bad questions here. So I definitely want you guys to ask whatever's on your mind. What are you guys working on right now?
Capstone project. Right now we're all just trying to find the next thing to do for the capstone project.
Okay, cool. Um, I can kind of go through the remainder of like what we didn't get to, for like how code suggestions work, if you guys are interested. Um, and then from there we can go over any other questions. Let me share my screen so you guys can see. Can you guys see my screen? Sweet. Um, so was there any questions on like this whole side of things, or from VS Code and how these two things work? Did you guys get time to look up any of these little details at all? Totally cool. If not, feel free to ask anything. But we can just pick up right off where we were at. Um, um, so basically, where did we leave off at? That we kind of ended at Duo Chat, right? That was the last thing that we were talking about. So, have you guys gotten to a chance to look at like the code at all, or look under the hood? If you like, I can kind of show you some of the code, uh, where to look for things for this. Yeah. Oh, there we go. We got our first question. Let's go.
So I have a slight question about code suggestions. So
Yeah.
I know that let's say you're in Microsoft Word and you're just typing and you know how like it brings up a word in gray and you press tab to like get the word. And I that's kind of similar to how code suggestion works, but it's not like AI exactly.
Yep.
Like so like what's the difference kind of like what makes code suggestions like, based on AI or versus the other thing that just knows the next word to pick, if that makes sense.
Yeah. Yeah. That's a great question. So I'm thinking how to break it down. So we'll go to the right here. So we have our little VS Code app, right? Just like this. Why is the text so small? Let me make it bigger. I'll zoom in for you guys. There we go. And so we have VS Code here. Um, we can also probably, I mean, I don't know how Microsoft works under the hood. I have a friend actually who works on those products actually. So um, I did remember he said the API is actually really similar because he's working on some startup related stuff that's actually similar to code suggestions, but for Microsoft Word. Um, but essentially, what happens is you first have um, the client, right? So um, let's just rename this to VS Code client, right? So this is literally like the editor's UI, right? So I pull up VS Code um, as an example here, and I start typing, right? and I'll show you guys the exact path of how, like, when you start typing, how it ends up to the thing. And it's related to code suggestions we're going to go over anyways. So hopefully this will also answer your question. But you can imagine this user facing screen here is the UI, quote unquote, right? And we remember we went over before that in this realm, VS Code is essentially a combination of kind of a web UI and the Node.js server runtime, right? So what happens, and this is mostly on the VS Code API side, but you can also think of it as kind of what happens with DuoChat as well. When I start typing and it makes a suggestion for me, like just like this, like you saw here. So what happens is VS Code has this API called completions. So I'll send this to you guys. I'm trying to think. VS Code completions, maybe. It's actually, I think, called inline completion. So if you ever heard of the word IntelliSense, it's actually very similar technology at the end of the day. So I'll send you all this. Maybe I'll just send it in. I'll send it in Zoom if you guys want to link it to maybe the meeting agenda, whoever's taking notes. So it's the name for it is called IntelliSense. And then the technical name for what you just asked about, Yeshua, is basically the what's called completion. So really it's called inline completion. And this gets in kind of we'll get into more of what it means. I don't know why it's taking me to the same place. I'm assuming they have like an inline completion, inline completion. Maybe it's like inline suggestion. We'll do completion sample maybe. Let me try to find, I'll type in language server protocol. We'll get to what language server protocol is in a little bit. It's actually very fundamental technology that you guys should know about. So we'll get to that in a little bit. I'm trying to find the completion documentation. Yeah, so just look at this code here. Can you guys see this? See the code? Oh, what happened? Where'd it go? Here it goes. Can you guys see the code? Sweet. So you see this connection on completion. So on the VS Code side of things, and this is kind of roughly the same across a majority of editors, right? And actually probably the same on Microsoft Word. So when you make a completion request is what it is. So it's the same thing as when I go back to VS Code here and I start typing, and then it knows I stopped typing. And then you see it disappeared because it didn't pick up anything. But then it went back, and now it requested the editor knows based on some user behavior, like how fast the user is typing. Is the user in the middle of a word, end of a word, right? There's a bunch of business logic around that on the VS Code side of things. So as a perfect example, I just in the NeoVim world basically got the ghost text working on let's go back here. So you can see I have this little ghost text that's happening, building the logic on when it knows that when I've stopped typing. So I type like that, right? And then now it knows to go ahead and generate. It knows not to generate like while I'm in the middle of typing. So I had to build some logic because this doesn't come in with NeoVim. I had to build some logic that after a certain time period and whether a user is typing, does it meet that threshold, and then it makes that request, right? So that's how like the UI is probably doing its logic for making that request. And then how is like the code suggestion actually different than like like you said some regular autocomplete, right? And that's the whole world of what is called the language server protocol. So I'll just type in language server protocol. And there is an official website. So I recommend giving this a little bit of a read if you guys get time. And this technology, to put it simply, is fundamentally the technology that you use. This wasn't the case back in the day, maybe 10 years ago, but nowadays, majority of the stuff you guys do in an editor as an engineer is powered by this protocol. So whether you're doing HTML and like, let's just go back here, right? Ruby isn't really a great example because I'm not as good with it, but maybe we can find some JavaScript. Let's go back here. Maybe, or Go. Maybe let's do Go as an example, right? It doesn't matter. It doesn't matter the language, but so you see this here, right? And I'm going to delete this little line and I'm going to press control space. And when I do control space, what happens is the editor goes to all of the extensions that you have installed and makes a request against all of them, essentially, depending on what language you're using, right? And then it goes and hits a language server, and that language server does a bunch of analysis under the hood for providing all of this code. So remember the code that I just deleted, decode file entry, and I go back and I press control space. You can see that decode file entry is actually showing up, right? It's how you, as a developer, like if you go to Python and it auto completes a little bit of a function, or you're trying to see inside of an object or see inside of a dictionary, all of those features, basically. So you're not just writing on like, there's some people who are crazy and they write on just raw text and don't use these features that languages provide. But for the normal people, right, we like to have these things because we like to know what these data structures are that we write in our code, right? And so how does this actually happen? If we go back to our little chart here, remember that question you asked last time? I think it was Yeshua that asked it. I might be forgetting. You were asking, oh, how does it know how to activate all the extensions and do that in parallel, right? And how does it not block things? So when it goes through and activates all of these extensions, it registers extensions for a specific file type, right? So if I'm on a Go file, the editor knows that when I press control space, it knows that for that file, the Go language server is the language server to use, right? In making this request. And then what happens is it makes a request to the language server protocol. So we'll go back here. And we'll go to here, and we'll just call this we'll stick with Go because that was the easy example, right? So we'll do Golang, and you guys know what Go is, right? It's just basically another language. It's more of a backend type of language. Language server. We'll go down. Golang language server. So what happens is I'm writing some Go. I'm in a .go file. We'll make this text smaller. And so I start typing, and it knows I'm in a .go file. It knows that the Go language server is registered to this. So I don't know if you guys noticed, but when you go to VS Code and you're working with JavaScript as an example, JavaScript's actually built, I think, directly into JavaScript and TypeScript are built directly into VS Code. So those might not be good examples. But like Go, for instance, you have to go and like literally, like pun intended, you have to go install the Go language server. So when you install Go, it's titled as Go, but what you're really doing is installing the Go language server. Does that make sense so far? It's definitely a long-winded answer to your question, but we're basically covering this whole path. So that's where we're already kind of jumping into. Makes sense so far, or any questions? It's totally okay. You ask whatever questions you might have. Yeshua, do you have any follow-up question? Okay. So basically, as you're typing, it knows that you're in a Go file. It looks through all your registered extensions for that file. And then what happens is it registered? And so we'll actually remove this for a second, just to hopefully not be confusing, but we have the Golang extension. So this is actually kind of first what it does. So this Golang extension is considered the LSP client, meaning that it's just a piece of code that's directly interfacing with the language server. So let's go over here and let's go over here, just like this. And so it basically knows, hey, this Golang extension is registered to Go. And anytime it makes a completion request, remember when we were talking about this on completion? So this code is run essentially. And when this code runs for the completion request, the extension knows that it already started a Golang language server, like we just talked about, right? So it knows that this Golang language server is running, and we'll talk about how it knows that, right? It kind of seems a little bit ambiguous for now. So it knows that it's talking to the Golang language server and makes a completion, what's called a completion request. And there's multiple types of requests for all different types of things. So I'll go into an example after I write this. So there's completion or inline completion, sorry. Inline completion request. Let's make this way smaller than it is. So it makes an inline completion request. And for the code you're in, it does a little bit of static analysis. That's the real term for it. And then it says, hey, like like the example that I was showing you here, like we're referencing this zip artifacts, right? What is all of the related code for this zip artifacts logic here? And how does it do that? So it knows that this zip artifacts is a package, right? That's being imported. And then it looked at all the code in here and said, oh, here's all the code within that. Oh, I don't know why I didn't jump to it. Oh, here we go. We go into here. I don't know why the editor didn't do it. Oh, here's all the code. So it looks in all the code for zip artifacts as an example, and then makes a map of all of the functions. So you can see here it's got generate new metadata. What was the one that we were looking at? Let's go back down. I forgot what I deleted. Hopefully I don't actually mess anything up. Code archive not found. So let's go back, click on this. If you look in here, you probably can find it. It might be exported somewhere else in like another file. Maybe, yeah, it's going to be in here somewhere. Open file archive. I forget what method that we were looking for, but it's going to be in one of these, right? So just look at this open file archive as an example, right? So let's go back here and I type that and I type in open archive. It's going to know that that method is in there. So it knows that because what happens is it sends in this request, what line am I on? I am on, sorry, what line I am on. And in that case, it was what, line 69, right? And the column position is like X amount of characters. I don't know how many characters this is. I'm just going to guess 20, right? So you're on line 20. Let's make this small again. Sorry. Line 20, column 20, right? That's where the user's cursor is located. And then it goes to the server and says, server, hey, this user is asking for a completion for this line and this column. The server does all of its black magic, and then it sends back a response. And then the extension's like, okay, this response looks good. And then it sends it back to the user. So that's how a completion request happens. So whenever I start typing, and there's some autocomplete. So in this example, right? So it made a completion request to the extension, just like you saw here, and sends the exact same thing. And then remember, I was typing, right? And so my column position is going to be maybe 19 instead of 20 because it's not as far as when I press that, right? But when I press a dot, it knows that to send a different completion request. And that's getting into a little too into the weeds, but yeah, so that's how like a completion request works. And what this whole flow is language server protocol. So what I just taught you essentially is the essence of language server protocol. So it's kind of in the name. You have a certain language, a programming language that you're working with. You have a server that's always running, ready to take requests from the user. And then the editor is going to send requests to the server and get the response back and forth based on the type of request. So just like any other app, right? If you go on Spotify, right, and you're searching for something and then it pulls up a bunch of the results as soon as you start typing, right? It's kind of the same type of data flow. You're making a request and getting a response back. Does that make sense so far? Cool. So with this, code suggestions. So how does our code suggestions work? So one other thing that I want you guys to definitely learn if you don't know about this. So I'm just going to pick on London. London, do you know do you know what standard in and standard out is? Totally cool if you don't. You want to guess? You want to try and make a guess? She said no. So if anybody wants to guess, go ahead and try. Basically, standard in and standard out is the result of a program to a terminal. And I'm probably dramatically, and it's not really a terminal, but it's essentially, I'm trying to think of it, the logs of a computer process. So as an example, right, here, I have this production data logs here, right? So what's happening is the program is spitting out information. This is me importing like GitLab issues to my local GTK, right? So this program here, which is a script, or if I go like this and I press ls, right? What's happening is it's making a system call or a call to the program, and then it's reading out text essentially. And your editor or terminal or whatever you're working with knows how to deal with that text depending on the type of text you're getting back. So one thing I want you guys to learn, if you don't know the difference, is HTTP versus standard in, standard out. And you could even ask ChatGPT, hey, what's the difference between it? Give me some examples. That's what's great about these AI tools, right? So definitely, I want you to know the difference between this. This is like foundational knowledge for your career. And in engineering. So if you know this, like, you'd be surprised how many people actually don't know like the details of this, right? And even how HTTP works and how standard in versus standard out works. What's the difference between those? Or what IPC is, which is kind of the same thing. It's called. We can even just put that here. IPC, which stands for Internal Process Communication, which basically means it's sending a bunch of strings back and forth. And that's really the main difference. Actually, HTTP is a protocol. Standard in, standard out is not necessarily a protocol. Standard in, standard out is like your computer program is talking to another program. So like in this case, right, VS Code is talking to the language server, and they're both on two different processes. So like process one, right? Imagine like it's work, and these are kind of the same, usually the same process. Actually, I think we'll just say they're the same process. So there's probably some stuff I'm wrong about with that. But the second process, so this is process two. So like if I go to my activity monitor, I'll pull that up for you guys. So if I go to the computer's activity monitor and I type in VS Code, I'm not sure why anything is showing up. Maybe it's code helper, I think it's called actually. Code help. So as an example, you have this code helper, right? And there's a bunch of these. So these are all the extensions that are running for VS Code, and they all have their own process IDs. So you see this PID. So these are all process IDs, and that's what I just showed here is you have your, VS Code process, and then the Go language server process, and it's communicating over standard in, standard out. So I'll just remove the HTTP so it doesn't confuse you guys. If you want, we can get into that later. But it's communicating over standard in and standard out, this internal process communication. And this is foundational to how computers work in general, actually. So when you go to your activity monitor and you're looking at, CPU versus memory, right? And all these different programs, just know that a lot of these programs take one process from the computer, and your operating system manages these processes and where to allocate them on, the heap and the stack and memory and all that stuff that you guys are probably learning about in school, right? So hopefully it's connecting the dots a little bit. And so let's get into code suggestions. So is this clear so far? Like basically TLDR, I'll even show you a simple example, just so you guys can see it working actually. Let's pull up the console, and I'm gonna undo my change here. And we're in the console here. We're in the GitLab language server. So we'll get into the code suggestions part in a little bit, but you can imagine this is the Golang language server. I think maybe we can even pull it up. Go please server. I don't know how to turn on debug logs, so let's go back to the GitLab language server as an example. Let's go back to our Ruby program, and let's go down, and let's make a request. So you see how it's making, it's logging all of this stuff here. This isn't the actual complete logs of what's happening under the hood, but essentially what's happening is it's sending data to the other process, saying like, completion requests, something like this, right? This is what the client is sending as a string to the other, to the language server. So it's making a completion request, and it's saying, line 20 and column, 21. This is not how it exactly looks. It's just an example. And then the server is going to read that string. It's just a string at the end of the day. And then parse the string. And then once it parses the string, it knows, oh, it's making a completion request. It does the logic. And then it sends a response back. I forget what the delineation is. You guys can look in the protocol actually to see what that looks like. But it sends a response back and it says, function foo, right? And so then you get a completion with function foo. And that's the same thing here. So you can see all these logs that are happening underneath me as it's making code suggestions. It's essentially the same thing. It's just these are logs instead of like the actual programs, what's happening under the hood. Maybe there's another way I can show you. I think I can type in here LSP. Let me undo this. Maybe LSP client. Maybe it's LSP log. Yes. Okay, great. Let's go down. So we'll go to the end of the line. So you can see here it's making suggestions, requests. If I can scroll all the way to the right here. So yeah, you can see it's basically, doing suggestion requested. These are all the logs that are coming in and when the user makes a request. And then it's communicating over this string that I showed you, like similar like this, similar notation. And just a little bit as a tidbit, the structure the data looks like is called JSON RPC. So it communicates over this method. And then the data looks like this. Data looks like JSON RPC. And so, yeah, that's how the language server protocol works. And this is essentially anytime you're working on a new programming language, you'll now know kind of how stuff works under the hood. It's essentially for each language that you work with, this is a lot of what's happening, and a lot of community developers work on this technology for each language. And so our code suggestions is actually really similar. So I'll copy this. We'll go down and we'll type in code suggestions. And instead of the Golang extension, it's the GitLab workflow extension. Put this down, bring that down. So instead of the Golang extension, it's the GitLab extension. And then it's also the GitLab language server. And instead of doing static analysis, this is hopefully going to answer your question, Joshua. It's going to use the same thing. It'll look at, is this file registered, and it will stick with Go, or even in our case, it handles multiple file types. So so we have Ruby as an example, HTML, JavaScript, which would be .js, right? So we do code suggestions on all these different file types, and then from there, it checks if the extension is registered, and then the extension talks to the GitLab language server via this protocol that I was talking about. And then it says, hey, I'm on, line 20, column 20, give me a suggestion, right? And so what happens from here? So what it's going to do is let's look at the Go code, or let's do some simple code, like I forget how. I think it's like, let's do define hello world. Hopefully it'll give me a code suggestion. Come on. Don't fail me now. Maybe my thing isn't working. Oh, it kind of did something. Let me do a comment. Give me a hello world class. Cool. Awesome. So this is what we want. So you see it gave us a hello world class, right? So imagine I'm here, right? And then I press space, and then you can see how it auto completed hello world, right? So how does this all work together, right? So now that you guys understand how the technology works, you can see how we built code suggestions, because now it's all business logic from here. Because what happens is it made that request. So I'll accept it for now. We'll copy this code. Maybe we should have done a screenshot or something, but we'll copy it for now. Bring it back over here. Oh, that looks bad. How do I, how do I undo this? Maybe I can, maybe there's a way I can, yeah, there we go. Um, so the user's cursor is on, let's put that back, is right here, right? We'll put user cursor right here. And let's move this code to the actual request, right? And we'll say, what line am I on? What line is this? 1, 2, 3, 4, 5, maybe? Please let me know if I'm wrong. Line 5. I don't know where. I'll guesstimate maybe column 10, right? So that's where the user's cursor is. So you see user cursor here. We'll even highlight this in a different color so you guys can get this later, see it easier. That did not work how I thought it would. Let's make it a better. Okay, cool. But you can see the user's cursor is right there, right? So then what happens is it'll make the request. And then what we do is we extract the text, right? So what we'll do is, you change this back to black here. It'll split the code into two. And this is for code completion. Code generation is a whole other can of worms. We're just going to stick with completion. So just think about completion for now. It's going to do class hello world. So it's going to split it on half by half. Initialize, right? Greeting, I think, is the first part of it, right? So this is the first split. And then we'll make a line to show that it got split. I thought I was going to be able to write on that. Can I write on this line? I guess I can't. We'll just put a little bit. Code is split. Split in half. We'll make this blue like we did before. And then we'll take the last part of it here, which is this code. That did not work how I wanted to. There we go. So it splits it in half. And then what happens is we'll put a little arrow to here. And it goes to, without making it super complicated, because there's a ton of architecture under this, right? But at the end of the day, it makes a request to Google's Vertex AI. And super simplification, but what it does is it splits the code in half. What we call, we'll rename this. It's content above cursor. That's the technical name for it. I'll do this content above cursor, and then content below cursor. And so it sends each one of those and it says, hey, AI, what is the, can you guess for me what the user wants? And this AI is trained specifically to only provide code. So when you make a request to this model, you know how some AIs, and you ask it and it starts giving you like, oh, sure, I'll do XYZ, right? You don't see that happening. You just see the code magically appear, right? The reason why is because the actual LLM is trained to only provide code completion. And yeah, so that's basically what happens is we send the content above the cursor, the content below the cursor. There's a whole thing about context and stuff like that. It's more of the advanced stuff. But then once it gets back, we send it all the way back throughout front. So we get the response back from Google. The language server is like, this response looks good. And then we send back I'll just put a little arrow here. And we'll call it, I think it was completed with hello world, right? So sends back hello world. And then I'll put another arrow here. Sends back hello worlds. And that looks really bad, so I'll move it out like that. And yeah, so that's how it works. And then the editor knows to just show this as gray text. So this is something that's built into VS Code. Each client is a little bit different, right? So when I made it work in NeoVim, if I go back to this hello GitLab, so you see all this ghost text and stuff like that. I can send you guys the code if you want. When I made this work in NeoVim, Tomas actually had a really great initial POC, but when we got this working in NeoVim after with this ghost text here, this is functionality that really doesn't exist within NeoVim, but it comes out of the box with VS Code. And Dylan, let me know. Dylan is the JetBrains expert, so I don't know if that's the same for JetBrains, but yeah, that's basically how it works. Any questions? Go ahead. Yeah.
So when it sends it to Google's AI, is that like telemetry data or
What'd you say?
like does it use telemetry data when it goes to like the remote thing for the code?
No. So telemetry is completely different data. Telemetry is basically whether the user accepted the suggestion, right? Or the user like I accepted a suggestion, I rejected a suggestion, I told or I did X action. So it's basically our way of collecting user data, but we don't actually collect the actual code and stuff that the customers are sending. That would be bad. We collect whether the user did XYZ action, right? Which lets us measure the quality of how good our code suggestions are. So and we can dive into telemetry if that's something you guys are interested in. But when you think of telemetry, think of like analytics on the product itself. And then when you're talking about Vertex AI, just think about request response. I'm getting back this code suggestion from the AI. Does that make sense? But it's a great question. Because you'll probably hear like telemetry, like what is telemetry, right? And it's definitely probably confusing if you haven't seen all these things before. So yeah. Derek, Victoria, you guys got any questions? London? Nothing? Okay. Cool, sounds good. But this is basically how code suggestions work. And then to answer your question, Joshua, like the difference between Microsoft Word, right, and the rest, and these are code suggestions, right? And the autocomplete is really, it just depends on this back end part, right? For our code suggestions, we know it's talking to AI, so it's actually providing a AI response versus like Word. When you see autocomplete for a word, that's actually a lot of business logic. It's running through a bunch of algorithms to essentially figure out what the user is trying to say next or complete the word, right? But it knows all of the words in, the English dictionary and loops through those and figures out a word um, uh, that works for the actual, the user's what the user is typing. Hopefully that makes sense. But yeah, that's basically the major difference between something like Word and our code suggestions. But the front end part is very, very similar in a general way. Of course, the actual code probably looks way different. But yeah, let's move this here. And I'll make a little line, make this nice and pretty for you guys. Cool. So yeah, that's basically how code suggestions work, and that covers this part of the graph. And so now you guys know how our whole Duo suite is put together, essentially. So hopefully this helps for your capstone project if you guys are trying to figure out something cool to do. But yeah. Sweet. So there's no other questions. We can definitely end early. And if you have any, feel free to reach out to me. Maybe at the end we can do a like a Q&A if you guys have any questions, just let me know. We can schedule something. But yeah, hopefully this helps you guys. I'll send a picture of an export of everything that we made today. And yeah, Dylan, you have anything?
I have a question for you, Angelo, not related to anything we just discussed.
Okay.
Who would I talk to about like GraphQL subscriptions for streaming chunks in Duo Chat? Do you know anyone that like is an expert?
Aaron knows that very, very much. Yeah, for sure. Or Dennis. Um,
Okay.
DNYS.
Yeah, Misha,
He's on the
Dennis Misha. Yeah.
yeah, he's on the AI framework team.
Okay. Sounds good. So does AI framework handle that type of logic? I guess.
That's being like that's up in the air right now.
Okay.
So
Sounds good.
cool. All right, I'll stop recording. Uh, stop recording.